Good morning, dear students, and welcome back to the online classes of maths. Students, I am your maths teacher Nikhil Kohli. Student, this is the second video of the chapter 12, Ratio and Proportion. And today I'll start from proportion. So now let's study. So students, this is the topic I am taking, the first topic of today's video, proportion. And I've already told you about the ratio in my last video. If you haven't watched my video, then please click my video and watch the concept about ratio and the exercise regarding the topic ratio. So students, if two ratios are equivalent, or I can say equal, so if two ratios are equivalent, they are said to form a proportion. If two ratios are equivalent, not two quantities, two ratios are equivalent, they are said to form a proportion. Thus, proportion says that two ratios are equal. Two ratios are equal. Who says this? Proportion. Now, a proportion is an equation written in the form like this. This is the form. If I am taking four quantities A, B, C and D, so the ratio of A and B, A upon B, and the ratio of C and D should be look like this. A upon B is equal to C upon D. It means they are equivalent, means they are in proportion, because both these ratios are equivalent. So we can say the ratios are in proportion. Students, four quantities are said to be in proportion. Four quantities are said to be in proportion if the ratios of the first and second quantities is equal to the ratio of the third and the fourth quantities. If I'll say from here A, B, C and D, four quantities A, B, C and D, four quantities, and they are said to be in proportion if the ratio of the first and second, means A and B, like this, ratio of first and second A and B is equal to the ratio of third and the fourth quantity. C is the third and D is the fourth quantity. So ratio of A and B, first and second, is equal to the ratio of third and fourth, means C and D. So the symbol is equal to, or this proportion symbol is used to equate the two ratios. This symbol is used to equate the ratios. If A ratio B is equal to C ratio D, then A, B, C, D are in proportion. Once again, if A ratio B is equal to C ratio D, first and second quantity, third and fourth quantity. So first and second, the ratio of first and second, A ratio B is equal to third and fourth, C ratio D, then A, B, C, D are in proportion. This is the condition. Four quantities are said to be in proportion until and unless A ratio B must be equal to C ratio D. Means four quantities are said to be in proportion if the ratio of the first and second is equal to the ratio of the third and the fourth, like this. So students, for four non-zero numbers A, B, C and D are said to be in proportion if the ratios A ratio B and C ratio D are equal. That is, A upon B is equal to C upon D. That is, if AD is equal to BC, AD is equal to BC. This is known as cross product rule. In this rule, you just need to multiply this D A, so it will be AD, and B will go this side upwards, multiply like this. So cross, it is like a cross, cross, cross. So B will multiply by C and A with D with A. So AD and BC. So this is known as cross product rule. The numbers A and D are called here. The numbers A and D are called extreme terms. These two are extreme terms, and the numbers B and C, this one B and C, are called middle terms or means. Middle terms or means. So product of extremes is equal to product of means. Product A, B, C, D. A and D, first and the fourth are called extreme terms, and B and C are called the middle terms. These two terms, middle terms, extremes, middle terms, extremes, middle terms. So product of extremes A and D is equal to product of means B and C. Now students, I am going to solve exercise 12.2. So the first question, are 5, 20, 13, 52 in proportion? 5, 20, 13 and 52 in proportion. So first of all, we'll check the ratio of first and second quantities. So ratio of 5 and 20. So HCF of 5 and 20 is 5. So I have divided both the numerator and denominator by 5, which will provide you 1 and 4. So the ratio will be 1:4. Now I'll solve ratio of 13 and 52. So 13 upon 52. Now since the HCF of 13 and 52 is 13, so I have divided both the numerator and denominator by 13. So after solving, I'll get 1/4. That means 1:4. As you can see, 5:20 is equal to 13:52. 5:20, the ratio of 5 and 20 is 1:4, and ratio of 13 and 52 is 1:4. So therefore ratio of 5 and 20 and 13 and 52 are equal. Therefore five they are in proportion. So answer is yes. Answer is yes. Yes, they are in proportion. Now question number 2. Are 12, 15, 4 and 5 form a proportion? Let's check it. Solution 2. Ratio 12 and 15. 12 and 15. Ratio of 12 and 15 is equal to 12 upon 15. HCF of 12 and 15 is 3. Therefore, I have divided 12 and 15 by 3 and this is the answer. So, the ratio is 4:5. Now, the ratio of 4 and 5. Ratio of 4 and 5. 4 upon 5 and HCF of 4 and 5 is 1. So simply we can write 4:5 as 12:5 is equal to 4:5. Therefore, yes, 12, 15, 4, 5 form a proportion. Form a proportion. Now students, let's solve question number 3. Do the ratios 25 centimeter to 2 meter and 25 seconds to 30 minutes form a proportion. So the solution of it. So ratio of 25 centimeter to 2 into 100 centimeters. Students, you already know that 1 meter is equal to 100 centimeter and 2 meter will be equal to 200 centimeter. This and now 25. Students, the HCF of 25 and 200 is 25. So I am dividing both the numerator and denominator by 25. So I am getting 8. So the ratio is 1:8. Similarly, I am going to find out the ratio of 2 to 5 seconds to 30 minutes. 30 minutes. I am going to convert 30 minutes into the seconds. So 30 into 60 seconds, and this will give you 1800 seconds. So now 225 upon 1800 and 225. Students, the HCF of 225 and 1800 is 225. So I'm dividing both the numerator, this numerator, and denominator by this, and I'll get 1/8, or ratio 1:8. So ratio of 25 centimeter to 2 meter and ratio of 225 seconds to 30 minutes form a proportion. That's it. So that's it for today's class, students. I hope you all are understanding and enjoying my videos. Don't forget to watch my next video. Till then, take care, stay safe at home, and goodbye.